So this video is section 6.1, the area between the curves. So let's just take any function f of x here, and let's look at a curve underneath it, g of x. It doesn't matter what they are. And then let's talk about the area between these two curves from a to b. So what we're really looking at is we're looking at this area right here between these two curves. So we're going to start with the integral from a to b of f of x dx. Now you always have to have your integral and your integral with respect to x. Now when you find this area, what you're finding is you're finding the area under f of x. So that's everything in purple. So then let's subtract the area from a to b of g of x with respect to x. Now what that does is it takes out this blue stuff. So when you do that, what you're left with is just where the purple is there. We learned that in high school geometry, that we can subtract areas. Now you don't have to write them as two separate problems. You can say the integral from a to b of f of x minus g of x, all with respect to x. So that's probably the easiest way to think about it. There are some other cases. Let's start with if f of x is up here and g of x is under here, well, would we still subtract? So let's look at the fact that this is a and this is b here. So when you find the area under f, you're finding the blue. And when you subtract the area under the g, technically you're adding it, so you still come up with what you need. So we would say the integral from a to b of f of x minus g of x dx. So let's look at a couple of very specific problems. Not that line right there. Let's say that you have the parabola y equals x squared and y equals 2x minus x squared. So your graph is very important because you need to know which one you're subtracting and which one's on the bottom. So here we have y equals x squared, and it's a parabola that opens up. It looks like this, y equals x squared. And then we have y equals 2x minus x squared. Well, I know that I can factor out of x, and I have 2 minus x. So I know that I cross the x-axis at 0, x equals 0, and x equals 2. So I have an upside-down parabola looking like this. Now you just have to do a sketch. It doesn't have to be exact. So when I find the area between the two curves, I'm looking for this blue shaded area. So on this problem, we have y equals x. It's y equals 2x minus x squared. So what we need is we need the points where these two lines intersect, because they didn't tell us that. So we're going to go back to algebra, and it says that if we want to find where two lines intersect, we can set them equal to each other. It's technically the substitution, where you learn substitution, elimination, and graphing when you have systems of equations that are both linear. So it's technically that substitution. So this is a quadratic. We need it to be equal to 0. So let's subtract x squared to the other side. So this means we have 2x minus 2x squared. So to solve, I'm going to factor out a 2x because I really do like factoring. So we have 1 minus x. By the way, when you watch these videos, pause, write with me, keep up, do the math with me, think it through, pause and spend the time that you need to spend on it. So then we can say 2x equals 0, so x equals 0. Well, that was obvious from our graph. And 1 minus x equals 0. So 1 equals x. We can add the x to the other side. So this is how we find our points of intersection, is we set the two equations equal to each other, points of intersection. So that means that what I'm looking at here is I'm looking at 0 for x and 1 for x. That means this graph is not drawn to scale. Technically, this line should come up through here and be at 1. But remember, I told you it just has to be a sketch. It just means you can't read it. But we did learn in high school geometry that unless it's stated, you can't assume it. So keep that in mind when you're looking at these graphs. So now we're going to write our integral. I'm going to write it as 1. So we're going to integrate from 0 to 1. Now the top equation is the blue equation, and I labeled it down here to the right. So we're going to say parentheses 2x minus x squared. And then we're going to take away the bottom equation, so we're going to subtract the x squared, and then all of this is with respect to x. Make sure that you understand that that's where the shading is occurring. So we're going to integrate from 0 to 1, and we have 2x minus x squared dx. Now it's going to look similar to your finding points of intersection sometimes, and that's okay, it happens. So let's combine like terms, 2x minus 2x squared dx. I see a lot of students integrate at the line above. I don't know why, you have extra work. So let's combine like terms, and then we'll keep going. Now we can integrate. So when we integrate the x, we add 1 to the power and divide by the new power. So 2 over 2 is 1. Minus, we add 1 to the power to be 3, and we have 2/3 here from 0 to 1. Now we can evaluate. 1 squared is 1 minus 2/3, and then we put in 0. Don't skip that step. A lot of people miss it. I'm struggling with those lines right now. So we have 3 over 3 minus 2 over 3 equals 1/3. So the area between those two curves is 1/3. Okay, let's look at another one. This problem says y equals x over the square root of x squared plus 1. And your second equation is y equals x to the 4th minus x. So I would get a graphing calculator because I am not interested in actually plotting points and graphing this. I just need an idea what it looks like. So hold that thought for just a second. So take a minute, put both of those on your calculator, look at the graphs. Your calculator could help you find the point of intersection, but we're going to do it in math. So this is what the graphs look like. This tall one here is y equals x to the 4th minus x, and the long one is x over the square root of x squared plus 1. And then what we want to do is we want to zoom in so we can look at that area where we have the area between the curves, between the 2 points of intersection. So let me pause for a second and bring that picture in. Okay, so now you can see that we want to find this purple area, the area between the curves, and this long one is x over the square root of x squared plus 1. And this tall one is y equals x to the 4th minus x. I like to think of them in terms of stuff, so now let's find the point of intersection. So we're going to say x over the square root of x squared plus 1 equals x to the 4th minus x. This is a terrible problem to solve. So we say x equals x to the 4th minus x times the square root of x squared plus 1. And then we have x over x to the 4th minus x equals the square root of x squared plus 1. And this doesn't get any better to solve, I don't believe. I think it's just going to get messier. We're going to square both sides. So on the bottom we have x to the 8th minus 2x to the 5th plus x squared equals x squared plus 1. So if you multiply that to the other side, you get x squared plus 1 times this craziness, x to the 8th minus 2x to the 5th plus x squared. Now there's not really a good way to solve that. So let's talk about, use your calculator, and you can see this point right here is going to be between 1 and 1.25. The 0 we've got, x equals 0 we've got, is the other x that you need. So trace on your calculator until you come up with that number, or use your calculator in another way. So I'm not going to give you one that you have to do, But if you zoom in and trace it, you'll find the x equals, we're going to use 1.18. All right, so now we've got the integration from 0 to 1.18. Now, if you remember, this is like the example I was giving you earlier, where one is below the curve, one is above the curve. Kind of, at some points it's both. It doesn't really matter, because if we're completely above the curve, if we're completely above the x-axis here, then we subtract them so that we can find the area between the two curves. If we're completely below the x-axis, we still subtract them, so it adds that negative area. So you don't need to worry about the fact that part of it is above the curve and part of it is below the curve. So we're going to take the line on top is the long line. So we have the top equation is x over the square root of x squared plus 1. And we're going to subtract the other equation, x to the fourth minus x dx. Now, here's your problem. The first term needs u sub. So let's split the integral, because you can't do u sub in part of the problem and not in the rest. So we're going to say the square root of x over the square root of x plus 1 with respect to x, minus the integral from 0 to 1.18 of x to the fourth minus x dx. So let's let u be x squared plus 1. So du is 2x, and the derivative of 1 is 0, so we just have dx. So dx is 1 over 2x du. So now we can rewrite this, the integral from 0 to 1.18. And we have x over the square root of u. And then we have 1 over 2x du. All of that goes in place of dx. Now, very nicely here, we'll see that these x's cancel out. Well, that's very exciting, not multivariable calculus. So we have 1/2 times the integration from 0 to 1.18. Remember, that's with respect to x. And let's, instead of writing 1 over the square root of u as we're headed, instead of writing that, let's write u to the minus 1/2. Remember that du. Remember that the square root of u is the same thing as u to the 1/2. And if it's on the bottom, then when it moves to the top, it becomes u to the minus 1/2. So you change the sign of the exponent when you change the part of the fraction. All right, so let's continue with this part of it. So we have 1/2. When we add 1 to the negative 1/2, we get positive 1/2. The positive sign is understood, so you don't have to write it, sorry. When we divide by 1/2, we flip and multiply by 2. So we end up with that. And then we would write plus c, but we don't need to because we have bounds. And these bounds are 0 to 1.18, but remember they are in terms of x. So let's go back, and u is x squared plus 1. So 1/2 times 2, those cancel. So we have, x squared plus 1 to the 1/2. Well, that means square root from 0 to 1.18. Let's write it as the square root of x squared plus 1 from 0 to 1.18, because that makes more sense to most people. Now let's come back and do the other half of the problem. So we're going to pick up, let's pick up here right before we integrate, or this we can look at and integrate. So let's say minus the integration here of x to the fourth minus x from 0 to 1.18. My point doesn't want to show up tonight. With respect to x. So when we integrate this, x to the fourth becomes 1/5 x to the fifth, or x to the fifth over 5. Either one is good. Minus 1/2 x squared from 0 to 1.18. So I'm going to continue to bring this down. Well, now you have 2 dots. Can't have 2, just 1. 1 period. 1/5 x to the 5th minus 1/2 x squared from 0 to 1.18. All right, so now we're going to plug this in. 1.18 squared. I have a calculator handy. It doesn't have batteries. Okay, fixed. 1.18 squared is 1.3924 plus 1. Minus, when you plug in 0, you get the square root of 1, which is 1. Minus parentheses 1/5 1/5 times 1.18 quantity squared. No, quantity to the 5th. 1/5 times 1.18 to the 5th is 0.4576 minus 1. Normally I tell you go with 2 or 3 decimal places, but when you have something like this, 4 is a good plan. Minus 1/2 times 1.18 squared is 0.6962. Minus, when you plug in 0, you get 0 on both of those terms. So now what we have is we have 1.3924 plus 1 is 2.3924. And let's take the square root of that. The square root of 2.3924 is 1.5467 minus 1 minus, when you subtract those 2 decimals, 0.4576 minus 0.6962, you get negative 0.2386, and we all know that 2 negatives make a positive. So now we've got 1.5467 minus 1 is 0.5467 plus 0.2386 for a grand area of 0.7853. All right, let's look at another one. We're going to look at probably 2 more because I don't think this section is overly hard. I think that you just need to be careful, but there's 2 things that you really need to be aware of. The first one is, let's say we're going to look at y equals x minus 1 and y squared equals 2x plus 6. Now, we know that y squared is a parabola, but it's sideways. Let's start with that one. So let's solve this for x. So 2x plus 6 equals y squared. So 2x equals y squared minus 6. So x equals 1/2 y squared minus 3. Oh, I said y, but I didn't write it. 1/2 y squared minus 3. Now, y squared opens like this. Y squared is a parabola opening this way. So if you have a negative y squared, it's going to open the opposite way. Keep that in mind. And that's what we're going to talk about here. That's why we're looking at this one specifically. The minus 3 means we move 3 places to the left. 1, 2, 3 to the left. And the 1/2 makes it a wider parabola. It is compressed. So we have something that looks about like this. It probably goes out more, but we're just doing a sketch, so it's okay. Now we know that y equals x is a line that runs right through here, and when you take away 1, you're going to move it down 1, so it's going to run about like this. So let's put that back in. So we're going to have this line, and it's going to look about like this. So they're going to intersect at this crazy spot up here. Now remember, here we have x equals, let's call this the brown line. This is x equals 1/2 y squared minus 3. And the blue line is y equals x minus 1. And you're looking for the area between the two. Now when you read in terms of x, when you work with dx for area, when you work in terms of x, you're going to read from top to bottom. And for when you're working in terms of y, you're going to read from right to left. So when we look at this, what we're really doing is we want to go this way. It's because when you find the area underneath this curve in terms of y, it goes to the y-axis. So this is the part it looks at. It goes to here. And then when you do this one, it's the upside down one, so it adds. Here's your goal. You're going to read right to left when you're working in terms of y. And what I mean by in terms of y is everything is, all of it is, y is the variable we're working with. Everything is in terms of y. So in terms of y, this brown line, we've done this well. We have x equals and everything is y on the other side. But the blue one, we haven't done that yet. So let's say x minus 1 equals y, just switch them. And then x equals y plus 1. Now we need the points of intersection. So let's take 1/2 y squared minus 3 and set it equal to y plus 1. It's a parabola. I don't like to work with 1/2 y squared, so let's multiply every term by 2. So we end up with y squared minus 6 equals 2y plus 2. And because it's a parabola, a quadratic, let's pull everything to one side. So y squared minus 2y minus 8 equals 0. We subtracted both on both sides. And then we can factor. If you're not good at factoring, the quadratic formula can be your friend. So I'm going to put a 4 and a 2. And we have a negative 4 and a positive 2. So then y equals 4 and negative 2. So that means this y here is negative 2. And this y up here is positive 4. Those are our bounds. All right, so we're going to go the integration. Now remember, we're going from right to left. This is the way that we're going. When we read, quote, top, or which one comes first. Technically, if you read it as outer instead of top, but almost all of them that we do are in terms of x. So it makes more sense to think in terms of top and bottom. And our bounds are from negative 2 to 4. So our bounds are 4 and negative 2, just like here. And then we're going to work the blue minus the brown equation. So our bounds are negative 2 to 4. If I could zoom it so you could see it all, I would, but I don't have that capability in this program. We're going right to left, so we're doing the blue minus the brown. So the blue is y plus 1 minus 1/2 y squared minus 3. The blue minus the brown, dy. You always have to say you need your dy out there. It tells you what variable you're integrating with respect to. If we had other variables in there, then they would be constant, so it wouldn't affect it at all. Now let's subtract and combine like terms. So we have y plus 1 minus 1/2 y squared plus 3 dy. Combine like terms. The integration from negative 2 to 4. It doesn't matter what you write first. Let's write the leading term first. Negative 1/2 y squared. We don't like it. It looks bad, but it's all right. Plus y plus 4 with respect to y. All right, so as we integrate, we're going to leave the integral symbol off. It's important that you have proper notation. That's one of the things I will look for as I grade your quizzes. I'm looking to see that you're doing math correctly. You can't just say, I found a way to do it on the internet or on my calculator. Those things are bad for you. They will not help you be successful. So let's integrate. So we have negative 1/2. And then we have y. When we add 1 to the power, we get third. So we have the fraction of 1/3 in front of that. Plus, when we integrate y, we get 1/2 y squared. When we integrate 4, we get 4y from negative 2 to 4. So this makes negative 1/6 y to the third plus 1/2 y squared plus 4y from negative 2 to 4. Now, we're going to evaluate. So when we plug in a 4, we have a negative 64 over 6. 4 to the third is 64. 4, 16, 64. Plus 4 squared is 16, and half of that is 8. Plus 4 times 4 is 16. Minus f of negative 2. So we have negative 1 over 6. Let me write that differently. So we have negative, and negative 2 to the third is negative 8 over 6. So that becomes 8 over 6. Plus 2, negative 2 squared is positive 4. Half of that is 2. And then I have 4 times negative 2 makes negative 8. So this is both divisible by 2. These are both divisible by 2, so we're going to say negative 32 over 3 plus 24. Let's take the parentheses off. Are y'all good with that plan? Because I like that plan. Minus 4 thirds minus 2 plus 8. Technically minus 6, but that's okay. We'll run with it. Negative 32 and negative 4 makes negative 36 over 3. And let's combine the integers. 24 minus 2 is 22, plus 8 is 30. My pencil doesn't want to write. Oh, well, there we go. So this makes negative 12 plus 30, which is 18. Now, you can't have a negative area. So if you got a negative area, you did something wrong. All right, so this will be part 1 of the video. I'm going to do one more problem for you. You need to see a problem where probably a trig problem will show you the best. We'll see. Let me give you one more hint before I turn off this video. So there is a problem somewhere that looks something like this craziness. Let's extend this line this way. And then let's put a horizontal line in here. So I should have put colors on them. So let's make this the blue line right here. And let's make this one the purple line. And we'll leave the horizontal line as the boring gray line, because horizontal lines are not exciting in calculus. So what you would have to do here is split this one into pieces. So like in high school geometry, I know I keep referring to it, but it's calculus with geometry. This is area 1, and this is area 2. So when you look at area 1, you would integrate the blue line minus the gray line with respect to x. That would be area 1. And area 2 would be the integral of the purple line minus the gray line with respect to x. Now, the reason that's important is because the purple line is on top all the time, but it has nothing to do with the shading happening in area 1. So that's something to think about. Your shading, your line has to be a boundary for the shading, so keep that in mind. All right, so we'll do one more video, and in that I'll do a couple more problems for you and with you. Have a great day.